Hello, eighth graders. If you are watching this, this is going to be the introduction, I guess not introduction, but the guide to going over the topic of relations and functions. If you are struggling on this quiz, which was a challenging quiz from the beginning of the semester, this will cover everything you need to know to do well on that quiz. So we'll get right into it. So this is relations and functions. Relations came first. We talked about that at the beginning of the semester, and then we talked about functions. So I'm going to jump back a little bit and do some illustrations, and then I'll get into the questions that you'll see in the quiz and try to relate them back to um, the material that you're going to see in a second. Okay, so I introduced this topic by talking about a situation. Here was the situation. Um, I said, hey, after school today, one of my friends invited me to go to the movies at 5 p.m. And here in the image, Miss Keller, which is one of the other eighth grade math teachers, she's pictured on my, I guess my right in the picture, but if I'm looking at the screen, our left. And then, so at 5 p.m., she invited me to go to the movies. Okay, great, love the movies, awesome. So a different friend invited me to play miniature golf with them at the same time at 5 p.m. And that was Miss Adkison, who is pictured there on the other side, right, with the golf club, another eighth grade math teacher. So the question is, what should I do, right? Both have invited me to go somewhere at 5 p.m. on the same day. So, I posed this in class and there's a bunch of different responses. So think about what your response would be for a moment. Maybe pause the video. So most people would say, hey, why don't you, the typical answer was, hey, I would, whoever asked me first, like maybe Miss Keller asked me first, and so I should probably just go with her and then ask a reschedule with Miss Atkinson, right? Very reasonable response. What I didn't get ever was someone saying, "Hey, just go to both, right? You can just be in, both. Just go to mini golf and movies at the same time, right? No big deal, right?" Okay, no one suggested that because that is not possible, right? Not physically possible for me to be in two locations at the same time, right? So this is somewhat related to the idea of functions. So let me illustrate what I mean. So in a function is simply um, a relationship in math in which the domain, okay, the domain, which you're going to see here on the board, domain would be my left side, and then the range is on the right. So domain or x values is assigned only one item in the range. In other words, I'm assigned to one item. Okay, we'll eventually put this in the numbers, but let's put this into a simple illustration, and maybe silly as well, of me and location. If you remember, we did this with people on the left, right, and locations or destinations on the right. So let's just say, hey, can this work? We'll look at three scenarios, and all I want you to think is, will this work or not? So scenario number one, on the left are X values, me and you. So put yourself in here, right? I'm going to the movies and you are going to mini golf. Will that work? Will that function, right? That's the question, right? And if you're saying, let's see, uh, me going to Mr. Brewer going to the movies and I'm going to mini golf, yeah, of course that'll work. That's fine. Okay, so we're going to give a green check mark to that. Yes, that will absolutely work. That's totally okay. Okay, let's look at a second scenario. So in this second scenario, which is in the middle, we're looking at Mr. Brewer going to mini golf and you also going to mini golf, right? And while that might be embarrassing to see your eighth grade math teacher at mini golf, it will actually work. Okay, in other words, we both can be at mini golf at the same time, so that again we can circle yes, that one will function. That's okay. That'll work. All right, let's go to the third scenario. In the third scenario, um, you can see that I am trying to be in two places at one time, right? I'm attempting to go to the movies and to mini golf, and you are trying to go to mini golf. Now, your scenario will work, right? You can go to mini golf, but I certainly cannot be in two places at one time. And so therefore, that is not possible. I'm going to say, hey, that's not going to work. Now, what is the illustration here? Like how would I interpret this in another scenario? So essentially what's happening here is I'm going to actually jump to another slide. Um, and I have what we're looking at is a bunch of XY values, right? And so I'm going to look at one illustration down at the bottom. So I'm going to draw your attention to the bottom scenario right here. And I'm going to illustrate what we just saw with me trying to go to two places at once. Okay, so we have a bunch of different numbers. So we have 3, that's paired with 4. We have 5 paired with 2. And again, all I'm doing is looking at these ordered pairs in this set of data, okay? We have 5 paired with 6, and we have 7 paired with 3, okay? So let's break this down. Again, we can use the illustration of people and places. So let's say that we're going to just assign some names. This is Sally. Sally is represented by the number 3, okay? And Sally is trying to go to, we're going to say 4 is the mall, right? For lack of more creative destination, right? So, okay. And then we got Bob. Bob is 5. So anytime I see 5, that's Bob. Okay. So Bob, and then let's say 7 is Jill. Okay. So Bob is heading to 2, which we're going to say is golf, right? Mini golf. We'll just say golf. Okay. And then 6 is the library. And then on the last but not least, Jill is headed to coffee, right? Coffee shop. Now, if you haven't noticed, we have a problem. And the problem is the fact that good old Bob is trying to be in two places at once. So we have a repeat of the X value. We have a repeated X value and 2 different outcomes, 2 different Y values for the same X value. That is a problem. Okay, let's look at one of the. I'm going to add one more thing to this. So we could simply look at our X values and say, hey, red flag, I have 2 X values and 2 different outcomes. I have a 2 and a 6 as my outcomes. That means I have someone trying to get to 2 places at once, or repeat in 2 different places at one time, and that's not going to work. Okay, so again, this is looking at from a numeric standpoint. In other words, looking at the numbers, why a function does or doesn't work. Okay, so obviously our answer for this one would be no, it doesn't work. We click the orange X. Let's add one more thing to the scenario just to make this clear. So let me add one more number. Let's say I add the number 6, and I'm going to add the number 2, right? So what does this represent? Well, we'll say that this is John, and John is going to, you'll notice that there's another number 2 up here, right? That's golf, so that means golf, that is golf. But that actually works out, right? It's okay for both John and Bob to head to golf together, right? Or be there at the same time, all right? Assuming that the golf course can handle more than one person at a time, right? Which again, right? So that is okay. That totally works, all right? So repeated Y values are okay. Repeated X values are not okay, okay? All right, so that is the kind of the main idea of function. So that's kind of like the numeric side. I'm gonna, as we look at some of these questions, we're gonna look also at the graph side of this, and kind of try to interpret some of that, and I'll kind of help you guys along with that. All right, so let's go through kind of question by question what you could see on the quiz and kind of try to interpret that for you guys so you can get an idea of what you're looking at. Okay, so question number 1. We are supposed to select true or false statement for true or false for each statement. We says a straight line on a coordinate plane always represents a function. Okay, so let's look at graphically what we might see. I'm gonna upload a image here. I have one. Upload an image of. Let me quickly do this. Okay, so I've uploaded the image. Sorry, I want to get a coordinate plane on here so we can you can see what I'm talking about. Okay, so a straight line on a coordinate plane always represents a function. Well, again, remember this idea that as long as I don't have any repeated X values, right, I'm okay. like everything is okay. So let's go back and actually look at those numbers that we had and put it on a graph and see what it was. I should be able to use most of these. So 3, 4, 5, 2, and 5, 6. Let's start with that. So 3, 4, and I'm just going to put dots on here. So 3 on X, again, here's X, here's Y. So 3, 4 will be 3 on X, and Y, 3, 4, 5, 6, 5, 2, and 5, 6. So 5, 2 would be here, 5, 6 would be here, and let's see what the other numbers were. 7, 3, 6, 2. I'm going to skip the 7. Let's make that 1, 3, and 6, 2. 1, 3, and 6, 2, because I don't have a 7 on here. So let's make it 1, 3. So 1, 3, which will still fit, and then 6, 2. So what would that look like? Well, a straight line on a coordinate plane always represents a function. So first of all, let's just, at this point, what I would need to do is connect the dots, okay? And here's how I would do that. I can grab, let's expand this out so you can see a little better. Let's grab our line tool. Oop, let me unexpand that for a second while we get these dots on, then I'll re-expand. Okay, so if I were to connect those dots, it would look like that, okay? Now, there's one rule for when we graphically have, when we look at something graphically to tell if it's a function or not. We know that the rule is I can't have multiple x values. So you can see that our problem area is right here. I'll highlight this in red. This is the problem. We have two x values, right? 5 is producing both 2 and 6. We said that's a no. That's a problem. So what we do to check if something works if a function or not is do what's called a vertical line test. So all I do is I get my line tool and I draw vertical lines through my graph and just check to make sure it only hits at one location. In other words, I can draw a line anywhere and I'm looking to make sure I only hit at one location on each of my points. So far at the beginning, if we look at this from the beginning, right? So far, so good as they start out, right? Only 1 point there, only hits at 1 point there, only hits at 1 point there, only hits at 1 point there. And then I get to my place where I know it's not a function and I hit a number of places, right? In fact, this whole thing, if I already connect those dots, this whole thing is hitting, right? Particularly I'll put the black dots, particularly this point and this point, right? Those are no points. If I didn't connect the dots, it would just hit at those 2 points. But regardless, I hit at multiple same spots. This does not pass the vertical line test. The vertical line test says I may only hit the line, a vertical line, one time with whatever the function is. And in case the function is a line or the shape that is on the graph. Okay, so this doesn't work, right? So a straight line on a coordinate plane always represents a function. Well, that is mostly true. We could say mostly true, but there's one line which you might already have clued in on. There's one line that will not pass a vertical line test, and that is a vertical line. I mean, it's, so if I were to actually put a vertical line on the coordinate plane, there's that purple line. That's a vertical line, right? It is aligned, but guess what? If I were to do a line test on that, the line that would go through that would obviously touch every single point on that figure. So for that answer, we've got to say straight line coordinate plane always represent function. Well, it mostly does, like 99% of the time, but sometimes it will not when it's vertical. So that is a no. Okay. All right. Let me clear this page. Okay, and let me actually expand this out. Okay, I'm going to add that picture in again. So we're going to look at the next question. So okay, so we got our image back. Again, we know that the first answer is no. That's not going to work because there's one situation in which if I have a vertical line, a perfectly vertical line, which is a line, it will not work. Okay, it won't be a function. Okay, because it doesn't pass the vertical line test. Again, the vertical line test is simply a graphical way to check if I have only a single x value producing one y value. Okay, if it doesn't pass a vertical line test, it proves that I have multiple x values, right, with different outcomes, with several different y values. Okay, I'm trying to be in two places at one time, right? That's the deal. All right, so now we're going to say, hey, y equals 2x plus 1 represents a function. Well, I can actually graph that line and see if it represents a function. Let's see if it actually does. So what I would do with that, little refresher, I would start with my y-intercept. So b, right? Begin at the bamboo border before you move up or down the mountain. So I'm going to start with +1. I'm going to put a dot there, right? +1 on the y-axis. Right? That is my y-intercept. And then I'm going to go to and say, tell me that the slope is 2. 2, and technically the whole number 2 really produces the rise and run of it. It's really 2 over 1, and that's my rise and run. So the whole number 2 is equal to 2 over 1, which therefore gives me my rise and run, right? This is my rise, this is my run. So therefore I'm going to, from that point that I already plotted, I'm going to do a rise of 2 and a run of 1. So 2, 1, and there's my new point. And now I can plot my line. Okay, and the question is, will that pass a vertical line test? And you should be able to see that yes, clearly it will. I can put a bunch of lines vertically through it, right? And it will totally pass a vertical line test. It does not repeat any values. So and listen, I didn't have to do that because I know that any linear equation, right? This is a linear equation. This is not a perfectly vertical line. That would not work. A perfectly vertical line is a different equation. And so I know that this is going to work. So the answer in this case is true, right? This is true. This will totally work. So that is true. The equation y equals 2x plus 1 represents a function. So essentially, if anything is in y equals mx plus b form, it will totally represent a function. Okay, let's go to the next. Let's go to the next question. Okay, so for this next one, this is asking 1.05 graph the ordered pairs for y equals 3x minus 1 using x equals -2, 1, 2. Okay, so what do we do with that? So first of all, we have to graph at some point. Okay, but before we do that, the question is, well, how do we graph this, right? So what they're asking us to interpret this, right? So we are going to use the x values that they gave us and the equation that they gave us to plot this out. So let's start by rewriting the equation. So y equals 3x minus 1. So I'm going to write that y equals 3x minus 1. And you'll notice that they do have like this x value. So there's this x, and then they say, hey, here's a bunch of x's, right? We've got -2, we have a 1, and we have 2, right? +2 as our x values. Okay, so here's what we're going to do. We are going to substitute. So I'm going to take my first value, -2, and I'm going to substitute it into the equation for x, and then I'm going to solve. And what I'm going to get out of that, the result of that is going to be a y value. So that what I end up with at the end is an xy pair. I already know what my x is. My x is -2 in this case. And then I'm going to find out what my y is. And then I can have something I can plot on the graph. Okay, so let's do this. So -2. So I'm going to rewrite this. So again, y equals 3. Now, any variable right next to a number is multiplication. So this is -2 and then -1. And I'm just going to now solve this. 3 times -2, that's a -6, and then -1. Okay, I got two negatives, right? So two negatives put together becomes more negative. So that is going to be -7. So y is equal to -7. Great, now I have my y value. So we're going to put in here, -7. Okay, friends, guess what? I got my first point in the graph. -2, x, -7y. So let's plot that. So let's go to -7, that's -2x, and then down to -7y, meet them up, and that is where my first dot is going to be. We'll make these in red. So my first plot is right there. That's my first point on the graph. Okay, and then I'm going to do it again. So I'll do it one more time, and then you're going to do the third one. The next one is we're going to now substitute using the the next x value. So I'm going to use the same equation. Y equals 3x minus 1. Again, I'm going to replace the x. So I'm going to put the substitute in R1 into where x is. Okay, so equals 3 parentheses, that's going to be 1 now, minus 1. And I'm going to solve. Y is equal to 3. 3 times 1 is 3, minus 1. And then y is equal to 3 minus 1 is 2. And our original, again, our original x value is 1. And then we said the result was a y of 2. That is our second point. So 1, 2. So 1 on x and 2 on y. And that's going to be right here. Okay, and then I'm going to do it a third time with the third value, which is going to be 2. So I'm going to write my equation again. I'm going to substitute in my 2, my final 2, right? This purple one, positive 2. And I should get a third value, which I'm going to then plot on the graph. Okay, so that is what they're asking in that question. Okay, question number 3. What is the value of the function at x equals 5? Okay, so in this case, they're going to give you some sort of line, right? So I'm going to just draw a line here. So you will have some sort of line on the graph. And I am going to kind of run it like this. And I'm going to adjust a little bit, so kind of like is what I really want it to look like. Okay, so it's about there. All right, so now the question is, hey, what is the value of the function at x equals 5? Now this sounds like a weird question. My friends, this is quite easy. But let me walk you through it. So first of all, I want to find x where x is equal to 5. Well, I know that the x axis is this one right here. It's very small, but this is the x-axis, right? So I'm going to run my pointer along the x-axis till I find 5. Okay, there's 5, right? Let's highlight it. Here's 5. Okay. Now, what is the value of the function? Well, the function is really the line. This is the function. So I'm just going to put function. Here's our function. Okay, a linear equation or a line can be a function. That's one of the examples of a function. So that's our function. So we're saying, hey, what's the value of the function at x equals 5? Okay, that's kind of a weird question, but let's take it. So let's look at 5 and go up to the function, the line. Well, if I look at the function at 5, it is right here, right? I could put a dot there, the plot there, right? Okay. So at x equals 5, we can usually put the ordered pair, right? At x is 5. Here's what they're asking, right? Oh, that's bad 5. Let's try it again. At x equals 5, they're actually asking, hey, what's the y value here? In other words, what value is y when x is at 5 in the function? Okay, all I need to do is go over and track my line down from there over to the y-axis and ask myself, okay, where on the y-axis does it meet? And if you can see there, it is what? Yes, the number 7. So my value is 7. So my answer actually in this question is 7. 7 is my number, right? 7 is my answer. And all it's asking is look at the line. What is the y value at that specific point? So look at x, find your x value. That's 5 in this case, x equals 5. Track it down to the line, plot a point if that helps you, and then look over to the y-axis and say, hey, what's the y value when x is 5? There it is. In this case, it's 7. Okay, again, your question might be slightly different. That's all that question is asking. Very simple, but confusing if you don't know that, right? That's a confusing question. All right, here we go. Question number 4. What is the value of the function y equals 6x plus 4 when x equals 2? Well, guess what? We did a question just like this, and that was this one. This one, you had to graph it. In this one, you're just going to solve it. So what is the value of the function y equals 6x plus 4? Friends, we are going to write that equation. So y equals 6x plus 4. okay? And they told us, hey, guess what? Your x is 2, right? At x equals 2, okay, we're going to put that in here. So x equals 2. So we have x here, right? So friends, all we're going to do is substitute in when x is equal to 2 and see what our outcome is. So y is equal to 6, and then I have x plus 4. So I'm going to put that in. So I'm going to put -2 here. I'm going to solve that, plus 4. Okay, so again, we're looking at what is the value of the function for the rest of this, right? So let's solve it. 2 times 6 times -2. That's -12. And then plus 4. Okay, and so again, we're just solving that. -12 plus 4, that's going in the opposite direction. So -12 is going left, 4 is going right. They're going to kind of counteract each other. So that's going to become -8. So y is equal to -8. Okay, so our answer is, what is the value of the function y equals when x is -2? Our answer is -8. -8. Okay, so here is the last question. So this is question number 5 on the quiz. And this one we actually looked at before in the intro, like kind of interpreting. So select is a function or is not a function to correctly classify each relation. I find that this is very helpful if we make it, if I do a chart, right? Oops, let's not do red, let's do black. If I do a T chart and I just list out, hey, here are my X values, here are my Y values. And then again, let's think about that on the left side, these are people, right? Persons, right? And on the right, we got places or destinations, right? So what we don't want to see is a repeat of people in different destinations. Okay, so let's take our first set of numbers. So I'm looking at number 1. We'll call this number 1. So I got 2 and 2. And then I got 4 and 4. And I got 6 and 6 and 8 and 8. Okay, again, what we're looking for is repeats of X values. That's a no-no. So, I mean, you should be able to notice pretty quickly, we do not have any repeats, right? It's 2, 4, 6, 8. No repeats. They are all going to different destinations. They could all be going to the same destination so long as it's different people, right? They're not trying to go, it's not the same person trying to go to 2 different places. So this one checks out. This is absolutely a function. So we'll give that is a function. Great, let's go to number 2. Okay, so I'm going to erase my numbers, get rid of those, and we'll go to the next one. So number 2, and let's just list these out. So 0, 3, 3, 5, 5, 6, and 8, 4. So again, I'm going to ask, do we have any repeat X values? We got 0, we got 3, we got 5, we got 8. We do not. And in fact, we don't even have Y values repeated, though that's not a problem. So again, if you're thinking that this is a function, it absolutely is. So is a function. Again, no repeat values. Okay, not so bad, right? Let's go to the next one. Okay, final one, or not final one, but third one. So number 3, and let's again list them out. 1 and 2, 3 and 3, 4 and 8, and 6 and 3. Now we have our first repeat of a Y value, right? So we have a repeated Y value, but remember, these are locations. So if I were to put some names to this, right, I have, let's say Bob here in 3, and I got Sally here as 6, and they are both trying to go to, let's say, the mall. Will that work? Well, yes, both Sally and Bob can go to the mall at the same time. That is not a problem. They both can head to the mall and be there at the same time. Not a problem. No issues there, right? Okay, so that confirms that this is, yes, we have another function. Again, repeating Y values is not a problem. That's not a problem, not at all. Okay. All right, let's go to, there's information. Let's get rid of that one. So that one checked out. I wish there was a faster way to delete stuff here. Okay, last one, number 4. Make this purple. Okay, so number 4. So 3, 4. Let's just list them out. 3, 4, 5, 2, 5, 6, 7, 3. Okay. Well, and right now, hopefully your alarm bells are going off in your head and saying, "Hey, wait a second, Mr. Brewer. I see 2 X values that are the same, and they are producing 2 different outcomes." Right? So we got, let's say this is Bob again, right? Bob is 5. Bob is trying to go to both mini golf and he's trying to get to the movies at the same time, right? That is no good, right? And if you look at it in the context of just the table, right? Again, 5 is repeated, and then we have 2 different outcomes. That is the problem. So this one is our first, but last, not a function. This one is not a function. Okay, that's not going to work. That was terrible. Check mark. Let's try it again. That is not going to work. Right? It's not going to function. Bob is trying to be in 2 places at one time, and it's not going to work. Okay. If we were to graph this on a graph on a coordinate plane, we would see that those repeat values, x values, are on top of each other, and therefore we would not pass the vertical line test. Okay. All right, friends. That is, again, and that is in summary, 1.05 relations and functions, a step-by-step guide to the quiz. Good luck. Hope you do well on that quiz, and I'll see you guys in class next.